Okay, welcome back to part 2 of P4, where we're actually going to simplify rational expressions. So before we start, I want to talk about what rational expressions mean. If you look at the words rational expression, it is a ratio of two or more expressions. So we've been working with a lot of expressions, so let me give you one. We'll do a simple rational expression to begin. Let's do x squared minus 4 over x cubed minus 8. And I'm going to simplify this expression. Okay, so if I look at this, it's pretty obvious that I need to factor it, so I'm going to factor on top. If you need help factoring, go ahead and look on our previous videos. But if I factor this correctly, let's see, x squared plus 2x plus 4. So I know this was a difference of cubes, and I know this was a difference of squares. So this is all factored. And literally, I'm just going to look, and I'm going to cross out what they have in similar. So they have x minus 2 in common. So my new rational expression will be x plus 2 over x squared plus 2x plus 4. Okay, and then if I can simplify it more, I will. Just note that you have to think of x plus 2 as one entire term, so unless there's another x plus 2, I can't cross it out, and think of this as one term too. Just because you see two x's doesn't mean you can cross them out. And then the other thing is I might have to write a domain. So if I look at this, I need to figure out what values of x can it be. Well, if I look down here, x is squared, and if I set this equal to 0, we'll find out later, but it looks like if it's a polynomial, the domain's going to be all real numbers. Another way to write that is I can write this, r with 2 lines across it. That also means all real numbers. Okay, and the reason why this is all real numbers is because I'm squaring this, so this is going to be positive, and this is going to be 4, so there's really no chance for this expression to be negative whatsoever. Okay. All right, let's do another example. Example 2. I'm gonna try to combine this into 1. Okay, so this example, I'm going to do x over x plus 3 divided by 2x squared plus 3x minus 9 over x cubed minus x squared minus 6. Okay, so what I want to do with this is I want to factor each part of these fractions. And before I do that, I see this division, and I remember back in algebra, when I divide rational expressions, I'm actually multiplying by the reciprocal. So I'm going to not only flip this and change it to a multiplication sign, but I'm also going to factor everything. So x is already factored, x plus 3 is already factored. I'm going to put multiply. Now I'm going to flip these two. So this is going to go to the bottom, and this is going to end up at the top. So if I look at this, I'm going to factor out I have an x here. I'm going to factor out a x. So I'll have x squared minus x minus 6 over, and if I factor this correctly, it will be x plus 3, 2x minus 3. Sorry, getting super messy. I also look here and I can factor this more, so it'll be x over x plus 3 times x minus 3 x plus 2 all over x plus 3 2x minus 3. Okay, so if I look here, what can I cross out? And actually, I purposely did this problem. We couldn't cross anything out. If we had something we could cross out, we just cross it out. But since we can't really cross anything out, I'm going to write it all under one big fraction. So x squared times x minus 3 times x plus 2 all over x plus 3 squared and 2x minus 3. So normally at problems you would probably have something to cross out, but I wanted to show you that it's also possible that you factor everything and you don't have anything to cross out, and that you would just leave it as one big fraction. Okay, if you have any questions, write it in your questions box and we'll talk about it the day after.